So we're going to focus on, we're going to kind of break it up into, we're going to have prisms, we're going to have cylinders, which is kind of like a prism, but the bases are circles. Then we're going to have pyramids, and then we will have, what am I missing? Cones, and then spheres. I don't have the net of a sphere because the net of a sphere is actually really kind of difficult to draw. It's kind of weird, and it's not a lots of pieces put together. So today we're going to focus on prisms, but it is important that you can identify the net in the name. Now, when you name a figure, the name is actually the base of the figure. So there's no confusion here. If I call it a hexagonal prism, guess what the base is? It's a hexagon. If I call it a square pyramid, guess what the base is? It's a square. So there's not going to be any confusion there. The name of the figure has the name of the base in it. The only exception would be cylinder and cone because those don't have the word circle in it. Okay? So let's look at that first one, that first net. What is that? That is you see triangles there. So is it a triangular prism or a triangular pyramid? Yeah, it is. The sphere net is ugly. Yeah. Good. It's a triangular prism. So that's what that first one is. Let's go this way. Number 2, what would that be? So the clue is to look at the bases. The bases is whatever there's 2 of in a prism. Trapezoid. So how do we say that? Trapezoidal prism. Okay, number 3. Pentagonal prism. Everyone practice saying this out loud. Say pentagonal prism. Now, in that net for a pentagonal prism, how many pentagons are there? 2. How many rectangles are there? 5. So what conclusion can you make about how many rectangles are in the net of a prism? How many rectangles are there going to be? 1 for each side. Very good. So the number of rectangles, they're called lateral faces. The number of lateral faces is going to be the same as the number of sides on the base. The same as in. Remember in minus 2 times 180, that kind of thing? In. Okay, next one. What's number 4? Ooh, I don't think that's a prism. We're not in Kansas anymore, Toto. Good. Triangular pyramid. That one is a pyramid. So what's the difference between a prism and a pyramid? How many bases does a prism have? Triforce. 2. 2 bases and they're the same. How many bases does a pyramid have? 1. Now, what are the lateral faces of a prism? They're rectangles. What are the lateral faces of a pyramid? What are the lateral faces? Good, triangles. And we'll get more into this later. I'm just jumping ahead. Okay, number 5. Oh my goodness, super easy. Cylinder. Number 6. What's that one? Rectangular prism. Number 7. Be careful, you name it based on its base, so that's not a triangle or anything. What's the base of number 7? Good, square. Square pyramid. And finally, number 8. Hexagonal prism. Not hexagonal prism, hexagonal prism. Okay. Oh, let's do the trivia real quick. This one's random. In 2018, do you know what date Easter's going to fall on? Okay, so in a few years, in 2018, Easter is actually going to fall on April 1st. Gotcha! No, not kidding. It really does fall on April 1st. April Fool's Day. Okay, random piece of information. So today we're only going to talk about prisms. No pyramids, no cones, no cylinders, just prisms. So prisms in the real world, your pencil that you're using might be a hexagonal prism. It probably is, but they make round ones these days. Obviously, tissue box, a gift. A lot of buildings are prisms. Not all of them, but a lot of them are. This tent is a triangular prism. So we see prisms everywhere. write this down. This is a definition of a prism. There's a lot of good words in this definition. A prism is a solid with a pair of congruent bases in parallel planes. Write every word down. Let's talk about each of these words. First, it's a solid. That's the unit that we're in. We're in 3D solids. It's called the solids unit. So, with a pair, that's a loaded word. That means two. Prisms are going to have two bases. What's going to be true about their bases? Well, they're going to be congruent. One cannot be smaller than the other, or it's not called a prism. And they are, of course, parallel to each other. So we're not going to have one base level and the other base doing this. No, they're going to be parallel. So they're going to be congruent and they're going to be parallel. Okay, I'm going to throw lots of words at you. None of these would I ever ask you to just recall the definition. So if this definition scares you, don't worry about it. You just need to be able to, if I hand you a shape, you need to be able to point to which ones are the lateral faces. You don't need to recall that definition, so don't be scared by the definition. The lateral faces technically, though, are the rectangular shaped regions formed by joining the vertices of the bases of the prism. Yeah, I know. It's a lot of words. All we're saying, do we get those shapes? No. All we're saying is that the lateral faces are whatever connects the vertices of the base. So like this rectangle is a lateral face. This is not a lateral face because it's the base. So the lateral faces are whatever connects the base to the base. In a prism, I do want you to write this down. In a prism, the lateral faces are always rectangles. That's really all I care that you know about a lateral face. In a prism, they're always rectangles. Not in a pyramid, but in a prism. I think my click to reveal wasn't working on this one, but it's working on the other ones, so we'll see it in the other ones. Okay, what is a lateral edge? Once again, you don't need to memorize the definition. Oh, sure, I can show the net, Edriel, sure. Lateral edges, the common edge shared by adjacent lateral faces of a prism. Okay, well, I'm trying to get this net out. I'm going to click on the figure, and I want you to watch what happens when I click on the figure. So, on this first one, I'm going to click on it, and the edges are going to turn from blue to purple. Do you see? The ones that are purple now, those are the lateral edges. The other edges are not lateral edges, they're base edges. The ones that are purple are the lateral edges. Okay, watch the next one. Okay, they just turned purple. So, we're going to find out in a little bit that the lateral edges are really the height of the prism. They're the height. Here's the net. If you wanted to see the net, you wanted me to unfold it. So, the lateral edges would be right here. That would be a lateral edge. Bases. The pair of congruent parallel faces. Now, the only thing that students get confused about is that the base in a prism is not always the bottom. So in this first one, the base is the top and the bottom. Cool. Did you see how it became shaded? I love this stuff. In the second one, the base is whatever there's two of. Pair means two. So in the second one, the base is not a rectangle. It's not a rectangle. It's not a rectangle. In the second one, the bases are the triangles. So the prism is not always sitting on its base. It might be sitting on its lateral face. So the base, how do you identify it? It's whatever there's two of. Okay, the height of the prism is also called the altitude, and it's however long the lateral edge is. Another thing I want you to think of, height, is the distance from the base to the base. So how tall is your prism? It's however long the distance is from, what is this, pentagon to pentagon. The height of your prism is the distance from the base to the base. Base to the base. That's your height. Okay, you're going to see every now and then in your homework, you might see the word, in a right prism, blah, blah, blah. I just wanted you to know what they meant by a right prism. In our class, all of our prisms are going to be right prisms. We're not even going to learn how to find the surface area and volume of an oblique prism. But I wanted to give you a visual. It's like regular building, Leaning Tower of Pisa. Regular building, Leaning Tower of Pisa. All of our prisms are going to be right. So if you see the word right, you don't have to do anything about it because they're all right. None of our figures are going to be leaning over, so none of them are going to be oblique. Okay, like I said, this is one that students get really confused about. I put all sorts of values up there. I want you to confirm which one is the actual height of the prism. So in the green one, which one of those numbers is the height of the prism? Be careful. I can't trick you guys. Good. Some people would say 7, but the height of that prism is not 7. 7's the distance from the base to the vertice of the pentagon, but oh my goodness, no, it's not the height of the prism. So the height of the prism is whatever connects the base to the base. See how 9 connects pentagon to pentagon. The height is not always going up and down. What about in that second one? What is the height of the prism? Very good. I can't trick you. It's not 8. It is 12. The height of that prism is 12 because 12 is the number that connects the triangle to the triangle. 12 is the height, even though it's not going up and down. Okay, so every time we give you a figure, we could ask you 3 things. We could ask you to find the lateral surface area, the total surface area, and the volume. Let's talk about what these are. What are we actually finding when we find the lateral surface area? The lateral surface area is if you were to paint the walls of your bedroom. Usually you're not going to paint the floor, and I do realize that sometimes you paint the ceiling, but you usually don't paint it the same color as the walls. So, lateral surface area is like painting the walls of the room. The lateral surface area does not include the bases. You're going to paint everything except the top and the bottom. So in this net, if I were finding the lateral surface area, it would just be the rectangles. That's all it would be. It's like base times height. The lateral surface area is just the area of the rectangles. Now the total surface area is if you're wrapping a gift. You're going to wrap the top, the bottom, all the lateral faces. You're not going to leave anything unwrapped. Maybe if you run out of wrapping paper. But anyways, so total surface area would be all the lateral faces plus the top and the bottom, the bases. And then you know what volume is. Volume is the number of cubic inches in a solid. It is when you fill it up. You're filling. Okay. Or you don't wrap it at all? Yeah. Okay. Formulas. Let's just dive into our formulas. Get your notes out and write LA equals PH. What does that mean? LA equals PH. What if it's a cube room? You would still only paint 4 of the walls, though, if it's a cube room. I mean, I don't know. You want to paint carpet? Ooh. Okay, so the biggest thing that I need you to understand is that capital P is the perimeter of the base. When it becomes capital, anything capitalized is referring to the base. So how do you find the lateral surface area? You find the perimeter of the base, and you multiply it by the height. You find the perimeter of the pentagon, add up all the edges, and then you multiply it by how tall it is. Perimeter times height. Perimeter times height. Okay, let's try it. So here's my figure. What is the perimeter of the base? So the bases are the triangles. They're the purple ones. What's the perimeter of the base? I shouldn't have even given you the 10, right? You could have found the 10 on your own. Good. 24. 8 plus 6 plus 10. So it's like you're walking on the edges of the base. So the perimeter of the base is 24 centimeters. When it says height, that's a lower case h. It's the height of the prism, not of the base. It's the height of the prism. So what is the height of the prism? Once you have P, once you have H, you can easily find the lateral surface area. LA stands for lateral surface area. If I were to paint, if that was a room and I were painting the walls, then 24 times 12. 288, good, centimeters squared. Next formula. We're going to learn 3 formulas today, so you can number them if you want. Next formula. SA stands for surface area. The surface area is, that looks familiar. PH, we already did that. That's the lateral. So we're going to take the lateral surface area, and we're going to add 2B. Why are we adding 2B? It's no good to use a formula if you don't really know what it means, right? So now the total surface area is we're painting all the walls, but we didn't paint the ceiling or the floor. We want the total surface area, so we have to add in the ceiling and the floor. So the total surface area would be find the area of all these rectangles, but now add in the areas of the pentagons. So the 2B is for these pentagons right here. 2B, 1B, 2B. There's 2 of them. You're going to paint the whole thing. I want this whole thing blue. PH plus 2B. Now, capital P stood for perimeter of the base. What does capital B stand for? Capital B is the area of the base. So capital B might take a long time to find. Capital B is what we just spent a whole unit doing, finding the area of 2D figures. Okay. So we already found the LA. There's no reason to find it again. Never find it again. Just use it again. We already found it. It was 288 centimeters squared. Did I remember that correctly? Capital B. So, the base is a triangle. How do you find the area of a triangle? You need to do base times height divided by 2. Base times height divided by 2. This is what capital B equals. So you have to find the area of the base. If that's a triangle, that's going to look different than if it's a pentagon. So be careful. So what's the area of the base? Good, 24. And the total surface area. The total surface area is LA plus 2B. LA plus 2B, because there's 2 bases. Final answer. 336 centimeters squared. So if we needed to paint that entire figure, we would be covering 336 square centimeters. Let's keep going. This is a lengthy lesson. Volume is my favorite because volume to me is the easiest of all of these. Volume is base times height. Now, base, that's a loaded word. Remember, base is not just a number. Well, it is just a number, but it might be a long process to even find capital B. I just want you to remember that capital B is the area of the base. It's not just, just pick a number that I see in the base. You have to find the actual shaded region of the base, and then you just multiply it by how tall it is. Base times height. Oops. We have to actually do it, sorry. We already found capital B. Do you remember what it was? What's the height of this prism? See how easy volume is? Are you ready for this? Base times height, 24 times 12. And it is a coincidence that it equals the lateral surface area. It doesn't always turn out like this. This is the first time I've ever written centimeters cubed because the volume is 3D, cubed, centimeters cubed, not squared. There you go. These are the 3 formulas. With these, you can find anything you need to in this unit for prisms. These are your 3 prisms formulas, but you know that you're going to get to use your formula chart all the time, every quiz, every test, so don't worry about committing these to memory. All right. Let's just dive in. Let's find everything that there is to find about a hexagonal prism. How did I know it was a hexagonal prism? Hexagon is whatever there's 2 of. The name of the prism is whatever there's 2 of. Okay, let's call on names. What is the perimeter? Capital. Very good. 48. The perimeter means the perimeter of the base. Each side is 8, and there's 6 sides. So that's how we got that one. Karthik, what is the height? What does h equal? Cool. No calculation necessary. The height of the prism is 30. Now let's find the lateral surface area. Let's grab our formula. It is P times H. So Alton, what's the lateral surface area? Thank you. Did y'all get that? 1,440? We don't have units to deal with this time. Now, what does that capital B stand for? What are we finding when we're finding capital B? The area of the base. Now, when it's a base like this, I do kind of recommend you redraw it facing you. But if you can work with it inside the figure, that's fine. The base is a regular hexagon. So to find capital B, we're going to have to do apothem times perimeter divided by 2. All right, let's find the apothem. So this is 4 root 3, right? So to find capital B, it is apothem times perimeter divided by 2. We already know the perimeter, that's why I put that up there so quickly. 48 has already been calculated. Graham, what do you get for the area of the base? Remember, you do not put root 3 in your calculator. You put everything else in your calculator and then tack it back on at the end. So 96 root 3 is the area of the base. Graham, this one's really yours this time. Tell me the surface area, the total surface area. When you see SA, it means total surface area. Remember that it's going to be the LA plus 2B. Sorry, Graham's not here. Quan, yours. Good, that was the right answer. So, it's 1,440 plus 192 root 3. And you are not even going to think about combining those into one number, are you? You're going to keep them separate because it's an integer and a radical. Here, remember that volume is my favorite. It's just base times height. Beautiful. 2,880 root 3. Now, remember that radicals work just like variables. You're not allowed to add terms that are unlike each other, but you are allowed to multiply them. That's why our surface area, they're separate, but in our volume, it's just one number, because you are allowed to multiply a integer by a radical. Okay? So that was our only real example with actual numbers. Now let's just make sure that we can connect the name of the 3D solid with the real world object. I'm sorry if I'm insulting your intelligence. I mean, last night, my daughter in kindergarten, her homework was pretty much this. She had to shade everything that was a rectangular prism red and everything that was a hexagonal prism blue in kindergarten. So I'm probably insulting your intelligence by doing this, but let's just do it for fun anyways, okay? The sun. What is the sun? What is the sun? It's a sphere. What is the cell of a honeycomb? Here's a real-world example of a hexagonal prism. Ooh, what is a bowl with a lid on it? Good. It's a hemisphere. No, guys, picture a bowl. A bowl is a half of a sphere. It is a hemisphere. Ooh, what about the tombs of Egyptian rulers? Where did they bury them? Pyramids. Yeah, I didn't even put that as a square. I just put pyramid. What's a shoebox? What's a shoebox? Rectangular prism? Absolutely. What is a wedge of cheese? This one's a stretch because I know that one side is a curve. What's a wedge of cheese, though, for the most part? A triangular prism? It's close enough. I don't know if y'all know what a grain silo is, so I put a picture of a grain silo. You probably can't see it though. Make it larger real quick. Do you see what it is now? It's the gray part. What's the gray? Pretty close to a cylinder. You don't know what a bar of gold is either, that's funny. Oh, I put a picture of it because you might not know what it looks like. So cylinder, a grain silo is a cylinder. A can of spinach. Oh, we're going to use that one twice in a row. A party hat. There we go. Y'all have been saying cone a lot. Finally, we get to the cone. And then can you tell what a bar of gold is? Let's make this larger. Can you tell what that is? Nice. A bar of gold is actually a trapezoidal prism. Very good. So guys, we did one example together. We did kind of pieces of an example, and then we did that hexagonal prism. You've only practiced this one time. So homework in this unit is super, super important. You need to practice on your own, by yourself, at home, and you need to have something to check tomorrow. You need to have answers to check. So I really need you to do your homework, and have a good day.